Okay, so let's start the stream then. Okay, once again, hello everyone. Thanks for joining our Cloud Native Rosenheim meetup. This time we're talking about Kubernetes 1.22 and talk about everything new features, also deprecations, removal, and stuff like this. So really doing a deep dive on Kubernetes 1.22. Okay, so with me today is Philip and Dario. My name is Nico. We are all working for White Duck in the container Kubernetes DevOps space. But Philip, Dario, go ahead. Please feel free to introduce yourself.
Yeah. Hi, everyone. I'm Philip. I'm 33. I have 2 kids. I'm working almost 12 years in the IT industry. The last years, more and more with cloud and Kubernetes. And I also have the free actual Kubernetes certificates. So, yeah, that's about me. Dario?
Hello, everyone. My name is Dario Brozovic. I'm DevOps engineer at White Duck, and my daily topics are everything around Azure DevOps, infrastructure as code, and pipelining.
Okay, thanks. So before we get started, 2 more slides, a little bit housekeeping stuff. Once again, in case you're trying to a little bit late, though, this meetup is streamed to YouTube. So in case you don't want to be on the stream, please turn off your audio and video. If you are listening at the moment via YouTube and you would like to interact with us, ask questions, stuff like this, join the Zoom, please join our meetup group. There you will find the Zoom link and can join from there if you like to. Okay, so in case you have any questions, just unmute or put it in the comments in Zoom or YouTube. We will monitor both and try to answer them as best as possible. Okay, so last slide before we really get started. So just about the Cloud Native Rosenheim meetup. So we are a meetup since 2019, I think, but we rebranded. So we started as a Docker Rosenheim meetup, mainly focused on containerization on Docker, and there were an official Docker meetup. And then we rebranded us 1 or 2 months ago and also joined the CNCF Cloud Native community groups, and now a part of the CNCF community groups and now called Cloud Native Rosenheim meetup. So in case you would like to follow us, you will find us on Twitter, you will find us on LinkedIn and all the other platforms. Okay, but so let's get started. The agenda for today. So we're doing a brief intro into Kubernetes 1.22, the release itself, and then we will dig deeper and show you our selected new features. So there are many new features in this release. We picked some of the great ones out, at least those we like, and we'll show you in detail. And after that, we will also talk about features which were removed with 1.22 or got deprecated, and share some insights and some best practices here as well. Okay, Kubernetes 1.22. So the theme for this release was reaching new peaks. So basically, this was one of the biggest releases ever. So we had more than 30 enhancements in this release. So really a really big release. It got released on August 4th, so pretty much nearly 4 weeks ago. Still pretty new, so you might have played with it, but the big cloud providers do not yet provide managed offerings, so pretty early stage with Kubernetes 1.22. So it's great that you joined and listen to all the great features here. As I said, it's the first release in the new long release cycle. So the Kubernetes project decided last year to move from 4 releases to 3 releases a year. And this Kubernetes version is the first one in this longer cycle release channel. And Kubernetes 1.22 also shifts security first, so meaning lots of the new features and the stuff which got introduced or created or moved to beta is related to security topics, which is really great. And as I said, largest release ever, more than 50 enhancements. We got a bunch of features moving to stable. We had nearly 25 moving to beta. and also 16 features which got introduced as an alpha feature in this release. So really big one. And with that, I would like to hand over to Philip, who will talk about some of the new features and show some more details. So you're still muted.
Yep. Can you see my screen?
Yeah.
Perfect. Okay. So hi everybody again. As Nico talked about, there are a lot of new features in the Kubernetes release 122. So what we thought about is pick some features which are really help the engineers on day 1 and day 2 operations to have a easier and better day-by-day job with Kubernetes. So that's our pick. So if we miss something, let us know. If you don't agree with us, you can also talk with us. So I would start with the first feature. First small feature is namespace labels. Basically, when you work with Kubernetes, you know, there are by default no labels for namespaces, especially when you work with policy engines, with network policies. You also have to create your own label, let's say an own label. I'm missing the word, sorry. Own label. I'm missing the word.
Can I help, Philip?
Huh?
Can I help with the word?
An own label structure. Thanks. So you have to create your own label structure for your whole cluster and so on. This is now also the case, but Kubernetes now by default ships with their own label. It's called kubernetes.io/metadata.name, and the value is the name of the namespace. So this label is with every namespace now there, and you can use it with every namespace selector, like a network policies and where you want. So second feature, sorry, Zoom is a little bit annoying me here. I don't see my, oh yeah, okay. Okay, second feature, node swap support. Maybe for the cloud, people who use cloud Kubernetes, it's not that important for on-premise Kubernetes clusters, especially with kubeadm. Now, when you set up the cluster, you don't have to disable the swap anymore. So it's an alpha feature you have to enable it on the kubelet. Applications like Java or Node or memory-intensive containers could benefit from this feature. So, but the main benefit is for when you create a cluster, you don't have to disable swap anymore. Also, one thing is it's a global feature for the whole node, so you cannot configure it per workload. So, for example, you could create 2 nodes which have a swap enabled and could schedule your memory-intensive applications to this node. So I think it's a good feature if you need it. Then one small security feature, the unprivileged port, this CTL is marked as safe now in Kubernetes 122. So this is a feature where you can have unprivileged ports, so containers which are not running as root, bind ports which are under 1024. So basically, these ports which are below 1024 are ports which can only bind by the root user, and but this CTL, it's possible to also bind those ports now. This is really cool when you have already your containers in the way where you don't let them run as a root user. Also, small cool feature, a network policy endports. Now you can define a range of ports. So before you only had the port. Now there's a enhancement with this endport value. Yeah, I think this is clear from this perspective. When we talk about security and root and so on, there's also a cool feature graduating to alpha now. It's rootless mode. With this feature flag, you can let the kubelet, which is the core binary of Kubernetes, you can let it run in the kubelet in the user namespace of the Linux kernel. And so you have a kubelet which is really independent and not running as root. So the user namespace, for the people who don't know what it is a kernel feature, and basically you run it as a user, which running like have fake privileges. So the user think he's root, but he don't is root. So he's running with fake privileges, but he has enough rights to create containers and so on. So this Linux kernel feature, yeah. And when you run the kubectl version of Kubernetes, you can also have with this enhancement the Rootless control plane feature gate, and there you have also the whole control plane, the whole Kubernetes stack, like the API server, so running Rootless. So this is a cool feature, and like we discussed before, shifting to security first, really. Another cool feature, and also maybe a little bit underrated in this release, is the API server tracing. I think tracing is clear, hopefully for everybody. If not, we can maybe talk later about it. But often it's the case that we could trace our workload and see what's going on in the workload, but we could not trace our core component, the API server. And with this new alpha feature, which also has to be enabled, is a feature gate. And also you need to provide a tracing config file. But with this, you can basically trace the for example, authentication, authorization calls, how long they take, where's the bottleneck in your cluster, and this is a really cool feature. And also etcd, it's not a release in this release, but etcd in general has experimental support for tracing. What here is important is that this feature from Kubernetes uses the open telemetry format. So I think you will need the open telemetry collector, I think, as a daemon set or something installed in your cluster. And there's also an example picture here. It would look like this. There's a call to Kubernetes API, and you see on which stage, how long it took. So I think it's a really cool feature. And till now, I did not saw it often discussed in the news or something, but for me, it's a really good feature, especially when you have large clusters. Okay, then a new feature, which is, I think, bigger in the news, is the new PodSecurity admission control, which graduated to alpha. The PodSecurity policy, which was the what's this? Oh my god, Vorgänger. Successor, right?
Previous. Successor, previous.
The successor was the PodSecurity policies. They were deprecated in Kubernetes 1.21. And now with this release 1.22, there is this new PodSecurity admission controller coming. And the thing is like, what is admission control? Admission control is at the end a piece of software which is compiled into the Kube API server. This piece of software intercepts requests from the API server before they are persisted to etcd. So after they are authorized and authenticated, and before they are persisted, it will be intercepted and modified or something else. And Kubernetes at the moment supports 37 different admission controllers, where we have two special ones, the mutating admission webhook and the validating admission webhook controller. Basically, these admission webhook controllers are doing HTTP callbacks and modify the object or validate the object what they have. Okay, and admission controllers, they can be validating, mutating, or they can be doing both. And when we see this flow here, the admission control phases, that may be a little bit clearer for us. We have the API request here. We have the authorization, authentication, and then it's always like this, that mutating is before validating. So we have the mutating admission webhook. Mutating, I think maybe I missed it. Mutating is like modifying the object, or we can also talk about use cases. And then we have the validating, and then the persistent to etcd will happen. Mutating, like a good use case is, for example, we talked about labels. When we want to have label structure, we can create a mutating admission webhook, and then all our workloads which will be applied to the API server will mutate it, and there will a label will be added, for example. Or I don't know, we can add resource limits, so the what we can do is really unlimited, but we can modify objects. Validating at the end is like we can validate if their resource limits are set, and if not, the API calls will be rejected and not persisted. So that's basically the target of this admission controllers. We make a little throwback how PodSecurity policies are working or were working. We had to also enable the admission controller feature. There was a plugin on the API server. We had to create the PodSecurity policy, and we had to create a RBAC permission for the service account or for the user of the pod to use those PodSecurity policy. So that was a little bit unflexible and not so good usable for end users. So often when you use Helm or let's say when you use Helm and you have the charts from the upstream charts, they work with PodSecurity policies, but we as users, as cluster administrators, it was really not such a good way to work with them. So the new way is this pod admission controller. We cannot configure any policy. We have PodSecurity standards. There are free baseline provided by Kubernetes. It's privileged, which basically allow everything. It's a baseline with some restrictions and restricted, which allow nothing. So what we can do is we can define one of those free profiles for our workloads. Not for workloads, sorry, for namespaces. And enforcement can be done at 3 levels. We can enforce, we can audit, and we can warn. Warning is like we see it on the shell directly or on the CI, and audit, when we use this feature, the issue as the warning message will be persisted to the Kubernetes audit log. So we have to enable the Kubernetes audit log feature, and then we will see the audit events from the PodSecurity admission controller there. This PodSecurity standards baseline profiles, they can be only configured on namespaces. So we can add namespace labels to the namespaces, or we can apply admission configuration to the whole cluster. So what we can do now is we can do a small demo. You all see my screen, hopefully. What we can do first is we can check if we have this PodSecurity feature enabled on all our components. So as is a feature gate, we have to enable it on the API server. So it is here enabled with the feature gate PodSecurity. We have to enable it on the controller manager. This is also here enabled. And also on the kube scheduler. So we also see this ephemeral containers true here, but this will be covered later. And then we have a GitHub repository where we provided some code. But here, with this code, I will create 2 namespaces. One namespace demo enforce, one namespace demo audit. In this demo enforce, we will enforce the restricted policy profile. And in the other one, we will just use the audit and the warn mechanism with the also restricted profile. And also what you can do is you have an enforce version or like a mode version. You can use the specified 122 for this Kubernetes or latest. And here is the admission configuration, which you can apply to the whole cluster. So as you can see, the version label must be one of latest or specific version. So maybe with Kubernetes 1.23, we could also use the policy versions from 122. We have to see this, but would be logical for me, except. And then you can create exemptions, so namespaces which are not be covered, for example, kube system. As always, we don't want to any security policy here because there's our logic sitting, and this would be the admission configuration for the whole cluster. But what we do, we just go with the namespace things. Yeah. I still do not fix my shell. Okay. When we make a get namespace with show labels now, we can check. We can first see here this default label. My name demo audit. Here this Kubernetes created this label for me, Kubernetes IO metadata name demo audit with the value of the namespace. This is the default what we talked about. And now we have the PodSecurity Kubernetes audit version restricted. Okay, and what we can do now is this nice guy, Bishop Fox, has a repository where he created some bad pod examples. So we just leverage this and we don't create our own. So this is in our demo enforce, where we do not allow any, or where we have the restricted profile enabled. We will try to create this privileged pod. And what we do now, we get an error from the server. Error when creating this privileged container must not be, the security context should not be privileged true. We have allow privilege escalation and so on. So when we go do now again, get pods in the namespace demo enforce, we will see that there's no pod created here because our admission controller blocked this creation of this pod. Now we go to this other namespace, to the demo audit namespace, where we just applied our audit and warning mechanisms. And we try to create the same container or the same pod and see what's happening. Let's make it a bit clearer. Now we get a warning message that this pod would violate our restricted pod security profile. And what we can do now, we can also check if the pod would be created. We see our pod is created, but we get the warning message. If we would have the audit log enabled, we also would see the message there, but we don't have it for now. Okay. A small conclusion for me or for us is like the new replacement is less complex than the successor. So you just enable the feature gate, you create some labels or admission configuration and can use it. Yeah, it's really good out of the box, but it's not quite as flexible. So basically, there are some alternatives in the Cloud Native universe. So it's the Open Policy Agent, Kyverno, KubeWarden, which are maybe a better fit for now. But we would have to check where this is going with this PodSecurity admission controller, because the cool thing is like this is not an extra piece of software. It's baked into the API server, and we don't have to install anything. We can leverage just direct with enabling the feature gate. Yeah, but we have to see where it's going. Then the one feature also, the next feature also with security is the SeccompDefault profiles. Is graduated to alpha. We have to also enable it via feature gate and on the kubelet configuration. Now we can create Seccomp profiles for the whole workload or for a node, or rather than to configure it per workload before, because the before version was like we have to set a profile and then we have to enable it per workload. And this changed now. We can just enable the Seccomp and then we have it for all our workloads. But what exactly is Seccomp? It's a Linux kernel feature called secure computing mode. And basically, it restricts syscalls which are made to the system kernel. Syscalls are they are interfaces between applications and the kernel. So the applications do not communicate directly with the kernel. So they do it over libraries and syscalls. And with this Seccomp profiles, we can restrict which syscalls can be made to the kernel. So we can restrict, let's say, like this. Oops. We can, for example, this reduces the chance that Linux kernel vulnerability will be exploited. But it's not 100% chance, but we really allow the risk of having something. And what is the cool feature is that the container runtime engines. So at the moment with Kubernetes 1.22, we have CRY-O and Containerd supported. They shipping default Seccomp profiles. So before, Kubernetes will do, for example, when you run Docker or Containerd on your desktop, the default Seccomp profiles will be enabled to all your containers. But Kubernetes explicitly disables those profiles and set it to unconfined. This is something what Kubernetes is doing. And with the new feature, this will change because Kubernetes just changed the default Seccomp profile from unconfined to runtime default, and it will leverage the default profile which is shipped by the container runtime engine. And what we can do now then is when we activate this feature gate, all our workloads will have the Seccomp profile. This is runtime default. Oops, sorry. And we have to go there and say specifically for the workload, we don't want the Seccomp profile. So we have to set Seccomp to unconfined for our workload where we don't want to have it run. What we can also do, like the old version, is we can define a profile and save it on the host and then apply it to the workload, to other workload on the host, which is running there. Okay, I think this was everything from me. If there are any questions, maybe now is the time to speak up.
Well, let me check if we have some questions on YouTube.
Yes.
No, so far nothing on YouTube, but if you have one, just comment.
Okay.
All right, then I will take over.
Yes.
Let me share my screen. I hope you're able to see my slides. Thumbs up. Yeah, very good.
Yep.
Thank you. Okay, let's talk about ephemeral containers. Ephemeral containers are an alpha feature since version 1.16 of Kubernetes. They are still in alpha, but we decided to include them here because they are a cool feature and there has been a major change with the newest version of Kubernetes. So what is new? The API for creating them has changed. This means if you already use this feature and you decided to upgrade your cluster to 1.22, then you will have to upgrade your kubectl to version 1.22 as well. Older versions of kubectl use the old API and won't work for ephemeral containers. Additionally, you will need containerd version 1.5, and you will have to enable the feature in some of the components like the API server, controller manager, scheduler, and kubelet. Just as an additional side note, so you get a better idea of the current state of this feature, it is currently not supported with CRI-O. Let me switch here. All right. So what are ephemeral containers used for? Let's make a couple of assumptions first. A well-built container should be as lightweight as possible, right? So if you have containers running inside of pods, they should only ideally contain your application code, maybe your application binary, and required dependencies. This is not only performance-wise, but also from a security perspective beneficial. Now, you made all of that happen, and for some reason, your pod still crashes or does not perform as expected. And you ask yourself, what can you do? Since your container is well built, it does not contain a shell or any kind of debugging tools, which equals to you have no possibility or barely any possibility to troubleshoot your pod. This is where ephemeral containers come in place. With this feature, you can inject a container based on an image that you like or that you need into your pod, and you can try to debug it. So let's see this in action. Our demo will be running on a kubeadm cluster because version 1.22 is not available on AKS yet, or at least it was not available when we created the demo. Is my terminal visible?
Yes.
Okay, great. So the first thing that we will do is let's create a pod. We will call it demo, and it will be based on the Google pause image. And let's execute one command. We will see this one later. And let's start it. Let's wait until, okay, it's already running. So now let's assume that this is our application container, and now you're checking on it, and somehow it appears to you that it's not performing as you expected. Something is wrong, and you would like to take a look what is going on. So my first guess would be, yeah, let's try to open a shell and connect to it. And unfortunately, since our application is based on an image that does not contain a shell, we cannot do this. So luckily, we have ephemeral containers, and we can now try to inject a container for debugging into our pod. Let's see how this goes. So, okay, debug. Then we pick the pod we want. We specify an image, and let's say we want to base our debugging container on busybox, and then we add another parameter, which is the target parameter. With this parameter, we target a specific process namespace. Since we created our pod, our initial pod with the run command, process namespace sharing is disabled, and that's why we need this one, this parameter for target the process namespace of our main application container. Let's execute this one. And now we should get a new session. And now we are connected to our ephemeral container. And what we can do now is, for example, we can list a snapshot of the current processes. And what we will see is the process that we started earlier in our dummy application container. So if we take a look at the pod now, we will see that our pod has a new entry, which is this one here. We got a ephemeral container entry, and the container is called debugger, and then it's a short string. And we can see that it is running, and it started just a couple seconds ago. All right. Now, the thing with ephemeral containers is that once we did our research and we decide that it's done and we exit the session, then the container will terminate. So if now we try again, we will see that in our pod, there is still the ephemeral container, but it's terminated. And it is not possible to restart it again. So if you need to do some additional troubleshooting afterwards, then you would have to create a new one. It is also possible to create the containers without this parameter, but in that case, we would not be able to see the processes. But maybe you don't need this. Maybe you have other debugging tools that you need, like, I don't know, curl or ping, and that's how you could still use it. Yes, additionally to that, it is also possible to debug nodes with this feature. In that case, you would get a whole pod with the ephemeral container inside, which would also terminate when you exit the session. So it behaves very much the same way. Yeah, just as an additional side note. That's it so far for ephemeral containers, and I would hand over to Nico.
Thanks, Dario. So do we have any questions? So no questions in YouTube, but here in Zoom maybe? Anything? Okay, cool. So then let me share again my screen. Here we go. So thanks, Phil and Dario, for the great new feature. So I now have the pleasure to talk about the bad stuff in this release. So we need to talk about API and feature removals. So this means in this release, so basically Kubernetes 1.22, we do not have only deprecations, so deprecated features, deprecated API versions, but we also have APIs and features which get removed. So removing basically means you're updating to this Kubernetes version, and you then end up not being able to use this feature anymore. So this is something which does not happen in every release. So last time this happened was with 1.16, and next time after 1.22, it will be in 1.25. So we thought it might be a great idea to also talk about those features which get removed and give you some tips and tricks which you can do, maybe, or at least check prior you're updating your Kubernetes clusters. So also some of the API groups and features I will mention later allow to also retrieve and update source objects, even if they are configured to use all the API versions. But most of them will basically not work after you're upgrading to 1.22. So before we dig into the details of the feature removals, maybe just a short information about the general Kubernetes deprecation policy to make you aware when you're using a stable feature or a beta feature or an alpha feature, which this means. So we have 3 API tracks, and those 3 API tracks have different policies. Starting with GA, so generally available or stable, basically everything called V1, or maybe in the future V2 or anything greater. If those features will get deprecated, they will stay in Kubernetes for at least 12 months or 3 releases, so whichever is longer. So basically, if we're now deprecating in 1.22 a feature, it will not be removed before 1.25. For beta feature, this is a little bit lower. So if a beta feature gets deprecated, it needs to stay in the code for 9 months or 3 releases. And for alpha, and this is really important because not many of out there are aware of this, if it's an alpha feature, it can get removed directly. So basically, you're using an alpha feature in the current Kubernetes version, and then you're updating, and maybe it's gone, and only maybe it's shifted to beta, and only the beta version is available, and alpha isn't anymore. So to basically really make sure if you're using alpha that this version is still available in a future Kubernetes version. So those are the general deprecation policies. So now going over to the feature list of removals. First one is around Ingress and Ingress class. So for Ingress, we have the networking API in version 1, which is available pretty long. So it's available since 1.19. And therefore now it's time to remove all the versions. So there are 2 here. We first of all have the networking beyond 1 beta 1, so the beta version of the now stable version, but also the Ingress API before that one, which was the extension v1 beta 1. And both are deprecated for a long time, and now will be now removed, or are now removed from the Kubernetes code. So you need to make sure that you are updating your Ingress manifest to really be able to access your applications after upgrading the Kubernetes cluster. So this one is really important. Notable changes for Ingress class, there are no notable changes, so it's really just an upgrade from beta to stable. For Ingress itself, there were some fields removed and restructured, and I will show you in a bit. Basically around the backend service part in the Ingress manifest, and also the pass type is now required. So if you have an older Ingress definition, older Ingress manifest, and you do not yet define the pass type, you will have to in the future to be able to deploy it. So maybe you have a quick look at the samples here. So on the left side, we have an older Ingress one. So this one is networking v1 beta 1. And we are now here seeing, first of all, in this example, we have a pass type prefix here, but in this version, would be possible to skip that one. And then we have the backend with the service name and service port section. And if we now go to the new, or the newer version, the version 1, the stable version, you will see that this part has been restructured. So we have a backend here, and then we have a service where we need to define the name and the port with the port number in here. So really make sure in your existing manifest that you're switching from v1 beta 1 to v1 and also restructure your backend configuration here. But there are some more things which you need to be aware of. You should also check whether your Ingress implementation supports v1. So if you're using Nginx Ingress or any other Ingress implementation, doesn't matter if it's an in-cluster one or a cloud provider one, a cloud provider implementation, you should make sure that those are supporting v1. So the big implementations out there, they're already supporting v1, but you might need to update your running version. So if you have, I don't know, Nginx Ingress, which is, I don't know, you did not update it for 1.5 years, so we will be pretty sure that you will need to upgrade your Ingress implementation to support v1. And this is really important. So really check out your Ingress implementation. Also, if you're using the Ingress class feature, which is a newer feature, but still, if you're using it, you will have to migrate the Ingress class definitions from the annotation part to the new Ingress class name field in the spec section to stay up to date for the future. So still, the annotation works, but for the future, the right location is the Ingress class name in the spec field. Yeah, in general, please review all your Ingress manifests. So there are some tools out there, and I will show you a demo at the end, which you can use to verify either locally or in a pipeline or also in your cluster and see if you use deprecated and outdated APIs. Really important to update them before upgrading your cluster. Otherwise, your applications will not get exposed via Ingress anymore. So second big one is the custom resource definition. So custom resource definition is a possibility to extend the API server and introduce your own resources. And also here we have since some time, since 1.16, a stable version v1 of the API extensions. And because of that, it's now time also to remove the v1 beta 1 version here. There are some smaller changes. So basically, the scope is no longer defaults to namespace. So you really need to have to decide if it's a namespace custom resource definition or a cluster-wide custom resource definition. So there's no default anymore. And there were also some restructures in the spec version field. So they restructured a bit here. But really make sure if you're using custom resource definitions to also verify if your manifests are up to date and using v1. And also, if you build your own custom resource definition, it's one thing. On the other hand, most third-party tools, operators, and stuff like this are also using custom resource definitions. So also make sure that those third-party tools are also up to date and also support the v1 API extension, and make sure that those are supporting this before upgrading your cluster. So same with the webhook resources here. Kubernetes allows you to implement some webhooks, mutating webhook and validation webhook. You might be aware of them. So Phil talked about them earlier. It's about the admission controller here, and those webhooks to inject the mutating or the validation stuff. But also here we have for some time now, once again, 1.16, a stable API version. And therefore, once again, the beta version, v1 beta 1, got removed with 1.22. And we also have some changes here. So multiple default values have been changed in the definition. And also another big one is that the webhook name now needs to be unique. So before version 1, it was able to use a webhook name multiple times. Now it has to be unique. So in case you're using webhooks here, really make sure that the names are unique now, to get everything or to stay with a working webhook configuration here. And once again, also mutating, validating is also something which is part of third-party tools here. So if we're talking about Kverna or Open Policy Agent, so policy stuff and so on, those are also using the webhooks. So also check here if you're up to date if those third-party tools are supporting the V1 in the version you have installed on your cluster. So those have been the bigger ones, but we also have some smaller ones which might not be required for anyone. But you also have some the changes in the authorization API here for subject access review and furthers. Also here, there is a stable version available since 1.6, so pretty long. And now it's time to also remove this beta version here. Some smaller changes just in the spec group field, which got renamed to spec groups. Nothing more here, but still, if you rely on the beta version, you will have to upgrade your deployments here. Also for certificate signing requests, there's also now for since 1.19 the certificates API available in the stable, and therefore the beta also gets removed. Also here we have some smaller changes between some fields and some smaller restructure. So in case you need those, also be aware of that. And then we have some more removals. It's a long list, but at least without notable changes here, which basically means you just need to make sure that you're using the new supported versions, but do not have to change anything in your manifest. Once again, a pretty old one, anything around role-based access control. If you're using cluster roles, cluster role binding, role and role binding, you should use them. Make sure to stay with a stable version, which is also available pretty long since 1.8, because the V1 beta one also gets removed. So also here, make sure that all your manifests for your role bindings and so on are using the stable version to have your security in place. Same for storage. If you're using CSI driver or storage class and volume bounds and stuff like this, also here, the V1 beta 1 version for storage will get removed with 1.22, and all of them providing a stable V1 version, depending from either version 1.16 to 1.19. So it depends on the resource itself, but all of them are now using V1. So also in case you have any configurations manifest here, also update them to the stable version. So last but not least, last list of removals. Also, if you're using priority class for your workloads, also here we have this 1.14 a stable version with V1, and the V1 beta 1 gets removed. Same thing here for API services. The API registration is also now available in V1, and the beta gets removed. And last but not least, I don't think it's something somebody uses directly, but also for the leases, the coordination API also is available since 1.14 in the stable version, and the beta gets removed. So really a long list of removals here. And once again, we're not talking about applications. We are really talking about removals. So if you rely on one of the removed API versions, those will not be available after upgrading your cluster. So you should really be aware of them and check them prior upgrading. So about how to do and how to check. There are some tools out there which you can use to validate your manifest. You can either do it via CLI manually. You can run them in CI/CD. So basically, I don't know, checking them in pull requests, running build pipelines and stuff like this. And you can also validate within the cluster and just doing some audit stuff here. Talking about CLI tools and tools for CI/CD, we have tools like Kube No Trouble, we have tools like Pluto and also Kube Conform, which can help you. All of them are just CLI tools which you can use. If you're talking about in-cluster auditing, there's a great guide by Caverno, which you basically can use Caverno to audit and see if there are any deprecated APIs running in your cluster, and then acting on the audit and updating your manifest. Although with kubectl, you will get API warnings. So if you use any manifest and apply any manifests with kubectl, and you will also get a line and a warning with some detailed information. And also this feature went to stable with this Kubernetes 1.22 here. So, but let's do a quick demo here. So I have an outdated Ingress configuration here, called a legacy Ingress YAML. So it's basically networking API, but it's v1 beta 1. And as we see, we have a pass type in place here, and we have the backend configuration with service name and service port for this version. So it's basically will not work with v1 anymore. And we can now use, for example, kubeconfirm here. Sorry. Kubeconfirm. Use kubeconfirm and provide kubeconfirm the Kubernetes version we would like to validate. On this, we're saying, okay, we would like to validate in 1.18. And then provide the YAML as an input. And then we do not get any output. We do not get any error, so everything is fine. And everything works. If we now go here to, let's say, 1.22, and we know it was the v1 beta 1 version, so for which is not available anymore in 1.22, we should now get an issue here that the validation failed because they couldn't find any schema for the Ingress. So, which in this case basically mean Kubernetes 1.22 doesn't know the v1 beta 1 anymore because the whole API got be dropped from the code. So just an easy example here. So basically one command line and then a CI/CD pipeline, or just manually, and you will get an output, and you will know at least which manifest has an issue, and then can dig deeper and see, review the documentation and see if there are any changes or anything you need to know. Okay, last but not least, there's also a tool called kubectl convert, which is a plugin for kubectl, which can help you upgrading the manifest. Or you can either see, okay, I have to do something and do it manually, but you can also use kube convert and let kubectl convert your manifests to a newer API version. So let's see how this works. Once again, let's do a cut here. We have the name file, so network v1 beta 1. And if we now do the convert here, so we're doing kubectl convert, we're providing the input file, legacy Ingress YAML, and then defining the output version. And here we're defining, hey, I would like to get networking with v1 instead of v1 beta 1. And then I just do a cut and to get it highlighted again. And here we're seeing now the first one, the original one is v1 beta 1 with a backend and service name, service port. And now we're getting as an output v1 and the new backend configuration with service name, port, and number below port. So pretty nice. It works with all manifests and with all APIs. So you can just auto upgrade your files. Of course, you should review them before applying them, but it's it's one command and those get converted. As of that, this one is a plugin, so it's part of the official Kubernetes release and project, but it's not part of kubectl by default. So we'll have to download it, and I will have a link for you in just a sec. So basically, just download, just put it, install it in your kubectl, and then you can use it and convert your YAML files. Okay, last but not least, so we talked about lots of things here, and therefore we decided to write down some links where we find some more information. First one is about our GitHub repo. We'll find the slides and also find the demos we did, the official Kubernetes blogs about the Kubernetes 1.22 release, what's new blog for Sysdig, which is pretty nice. Aqua have written down some things about security features, and some further links like the deprecation policy, the pod admission controller, API serving, feature gates, and also here the link to download the kubectl convert. So with this, we are at the end of the talk, and are open for discussions or any open questions. So do we have anything here in the chat? Okay, we have some chat messages. Okay, Phil was already commenting. So do we have anything open?
No,
Before I read the
still
whole-
no questions. I'm observing also our YouTube channel, but still no questions.
Okay. Cool. So anything from the audience in Zoom here? So feel free to unmute and ask any questions if you have them. Okay. So yeah, if there are no questions, I think we will end this for today. And yeah, everyone have a great evening and hopefully see you in our next meetup. Bye-bye.
Thank you, Nico. Thank you all for being here.
Thank you, guys.
Thank you
Thank you.
for hosting.
Bye-bye.
Bye.
Bye-bye.
Bye.